Let's consider a context where our initial ray does not point in the 3 o'clock direction. A point starts at the position 0, 3, so it starts up here, and then travels counterclockwise along a circle that is centered at 0, 0. So the point starts up there at the 12 o'clock position and then travels counterclockwise. We're going to let theta represent the number of radians the point has swept out since it started moving, and then we'll let xy represent the point's coordinates. So what we want to do is represent this point's coordinates in terms of theta. So can we write a formula that expresses x in terms of theta and y in terms of theta? You might feel tempted to write something like x equals 3 times cosine of theta and y equals 3 times sine of theta, just based on a lot of the context we've already seen so far. However, when theta is equal to 0, if we look at when theta is equal to 0 and we plug that into these formulas, we'll get x equals 3 out of that formula and y equals 0 out of that formula. So if these were the correct formulas, then when theta equals 0, or the point hasn't moved at all, then x would be equal to 3 and y would be equal to 0, which would put the point over here, which would say the point starts at the 3 o'clock position. But that's not the context we're looking at. In this case, the point starts at the 12 o'clock position. So we can't use these formulas. We'll cross these out. Those are not exactly what we're looking for. Recall that the sine and cosine functions take a number of radians as their input, but it's a number of radians swept out from the 3 o'clock position. So when we input an angle measure into the sine and cosine functions, it needs to be a number of radians swept out from the 3 o'clock position. So what we need to do is imagine starting at the 3 o'clock position and decide how many radians this point has swept out from the 3 o'clock position. So to get from the 3 o'clock position over to this 12 o'clock position, we have to sweep out pi over 2 radians. So that from the 3 o'clock to the 12 o'clock position, that's sweeping out pi over 2 radians. And then we sweep out an additional theta radians to get to where the point actually is. So even though the point has swept out theta radians, we can think of this as having swept out theta plus an additional pi over 2 radians from the 3 o'clock position. So the point is theta plus pi divided by 2 radians from the 3 o'clock position. So radians, I'll just say from 3 o'clock. Now this expression right here represents a number of radians from the 3 o'clock position, which is a number that we can input into the cosine and sine functions and get something out that's meaningful. So since the point is theta plus pi over 2 radians from the 3 o'clock position, then x will be equal to 3 times our cosine of theta plus pi over 2, and y will be equal to 3 times sine of theta plus pi over 2. This, again, is because theta plus pi over 2 is the number of radians from the 3 o'clock position, and then the cosine and sine functions do what we expect them to do. Remember, they output a number of radii, so we need to multiply that by the radius of the circle, which in this case is 3.